Hello everyone! This installation release was created in order to outline the general concept of practical cases of our training course. In particular, the requirements for the desired qualification of the listeners, the annotation system used, the methodology for forming a 3D model building free in value design engineering, as well as the sequence of parallel and synchronous development of structural, functional and 3D models in the context of the stages of development of design engineering documentation for GOST or by GOST 2.103, corresponding to the stages of milestones of project implementation of the same name. The questions discussed in the video Value Design Introductory Case, Value Design Engineering Stages in the context of 3D modeling refers to the practical cases of Block 2, School of Value Design Engineering of training course Cost Engineering. The following keywords will be used as a part of the discussions of today's topic. The concepts of applying the value design engineering in the practical activity of design engineer will be outlined taking into account the system of the following basic assumptions regarding to the classification of the listener. The purpose of introducing these restrictions is my desire to save time for listeners of our course, which such business profiles as buyer and commercial negotiations, project management, management, HR, marketing, and managing accounting. I think any sane person should be honest with himself and understand that it's impossible to be at the same time a design engineer and marketer, a design engineer, the buyer, and so on. Due to the amount of work facing each of these specialties in practice, it's possible to both design engineer and a cost engineer in particular, because these two areas of activity are adjacent according to many criteria, such as the need to the formal structure of the project, the functional model of the product, the assessment of technological and economic parameters of the product, and etc. At the lower levels of abstraction of consideration, i.e., when the designing parts of assembly units, the functional list of work responsibilities of a cost engineer and design engineer can generally become almost identical, except that in PDM system, the cost engineer is responsible for the current state of analytical reports of the technical and economic parameters of the product, and the design engineer for the current state and coordination of design engineering documentation. In one of the first videos of the course Cost Engineering called Channel Overview, we have already introduced designation for such a specialist, sounding like a cost design engineer or a cost engineer of the first type. At the same time, we noted that the weak side of such a specialist, namely low productivity, as well as the problem of finding personnel with the necessary qualification, i.e. having practical competencies in the field of design engineering, economics, and value design engineering. Or if all three of above conditions are met to one extent or another, the use of value design engineering techniques can be as effective as possible. The principle of designating of practical value design engineering cases taking into account and structural and technological features of the group of parts and assembly units can be formalized in the form of the following classification. The designation in accordance with the above classification will be indicated on the first slide of practical cases. In particular, below in this case we will consider the features of forming a model tree for the bicycle handlebar bolt already familiar to us, for example made by turning a knurling from a steel circle, and the front wheel hub, for example, made of aluminum forgings and machining. And in accordance with the above classification, the first section of the case will indicate MCH met. I admit that the above classification may seem strange to a professional technologist or material scientist, but for the purpose of demonstrating the general principle of forming and information of value design engineering database, in my opinion, the designer engineer will, in my professional opinion, because of my first education that was in design engineering university, Samara State University. I think will do quite well. It should be noted that such a classification is extremely convenient when using the method of factor research, which was considered by us in issue number 9 of our training course. Since measures to reduce costs for parts manufactured through similar technological processes and from similar materials will obviously be similar. Among other things, according to the established tradition, individual elements of bicycles or motorcycles can be considered, to which I have some consumer interest. This list is quite narrow. In addition, it will be limited by the specifics of aviation industry, i.e. working with thin-walled structure, the presence of weight restrictions, and other principles inherent in the development process to this specific industry, and small scales, single and pilot production. Nevertheless, for the purpose of demonstrating the general principle of forming the value design engineering information database necessary for the practical use of functional and cost design tools, this is at first glance a modest list of parts, assembly units, and their corresponding technological processes, in my opinion, is sufficient. The description of the technical, technological, and other properties of the considered details given in the value design engineer practical cases is a simplified educational version of their real description and will be borrowed from open sources. In order to smoothly move directly to the practical tools of value design engineering, let's look at the details familiar to us from previous videos. In particular, the three of these models in which to pay attention to the factor proposed in issue number 7, object of analysis decomposition, formulation of functions, the method of conditional volumetric function carriers, the rule of avoidance surfaces, the rule of standard technological elements, and the method of setting the main function carrier are used not only formation of tabular structural functional components, but also information of a 3D model building tree, i.e. when forming into a tree of elements of groups of elements of construction combined into carriers of function corresponding to the same name, volumetric carriers of functions, as well as corresponding to the them and volume and appearance. In fact, the model tree becomes a kind of visualization of a set of volumetric carriers of function and is an element of the design culture of the design engineer using the elements of value design engineering in his work activities. Summarizing above, we can formulate the following basic stages of value design engineering in relation to the modeling. The first, parallel formation of structural functional model and 3D models at this stage. The second, synchronization of a structural model and 3D model tree with the following content. Third, synchronization of functional model with following context and stage. And the last, synchronous information of structural functional model and 3D models. I mean synchronous formation, not synchronization, but synchronous formation. Renaming and combining elements of the model tree is performed in accordance with the methods described in the issue number 7, object of analysis decomposition, formulation of functions. These methods we have at this slide. All these methods. If you need to repeat this material, you should have another study with issue number 7. If the structural model contains the same function carriers, for example, the same holes, the same flanges, the same threaded surfaces, they are indicated in the construction tree by the same name with the different indexes. For example, if you gave the carrier of the function hole for reference abbreviation HL, and we have 3 identical holes in the part which have the reference abbreviations HL1, HL2, and HL3 in the table structural model, then they will have a designation in the construction tree In terms of demonstrating the possibilities of value design engineering, the bold and Bushin parts, in my opinion, have little potential. Bold due to the fact that the design of the most of commonly used bolts is standardized and shown in the illustration in standards, GOST or ISO. About special drawing bolts and other special fasteners used by individual enterprises, this rule doesn't apply. i.e. special fasteners may be interesting for analysis. The front wheel bushing is firstly a component with a low potential and low reduction model. This concept will be discussed by us in the issue number 18, Cost Driver Model Visualization, Cost Reduction Action Plan for Object of Analysis. Secondly, a component whose design is formed mainly through evaluation and practical testing of the design of the front wheel of a bicycle, and not by methods of value design engineering, i.e. at the dawn of bicycle construction, there was just a bushing which had for this purpose the placement of bearing and the transfer of load from spokes and axis of rotation. Then, in the process of improving the design of bicycles, the function of installing a brake disc were added, then visual functions were added. In addition, the bushing is not the most successful example for the point of view of analyzing of power works of its strength calculations, because it includes only the calculation of the holes of the flange of cutting and cramping. In connection with the above circumstances, I propose to complete the consideration of these two super elements and the context of the value design engineering and move to the new examples of next issues in accordance with the classification proposed above. The installation case for the value design engineering should focus on the standard form of initial data for the practical case. This form is universal and can be used both for practical cases of our training course and in the practical activities of a cost engineer. The educational aspect of using the form when considering the practical cases of Block 2 can be described as follows. For each educational object of analysis, I will fill out this form for the object of analysis under consideration. Then, based on the available initial data, analytical reporting will be generated and interpreted in the context of making design engineering decisions. I use this form, among other things, when working with external customers of cost engineering services. The practical use of this unified form can be conditionally divided into two stages. First stage, before the conclusion of the NDA, or the stage of depersonalized data. Second stage, after the conclusion of the NDA and or the stage of full disclosure of the initial data by the customer of the services. At the first stage, the form is provided to the supplier in an impersonal format, which allows you to indicate the presence of certain source data or initial data from the general list by setting the places. The meaning of the first stage is that after receiving information from the customer about the amount of initial data available to him, it becomes possible to designate a list of services and the corresponding list of analytical reports, which can be specified taking into account the available volume of initial data. The logic in this case is simple. As more initial data is provided, the more accurate and complete a list of services and analytical reports is available to the customer. At the second stage, the form between the supplier and the contractor, if necessary, and NDA can be concluded, after which a contract for the performance of work is concluded, and the contractor on the part of the customer must be provided with a completed form in which the places are replaced with numerical and textual data. In addition, the customer must be given the opportunity to use the process of analyzing the other initial data, such as design engineering, technological documentation, CAD models, etc. As a rule, the contract provides for the possibility of additional consultations from specialists of various profiles who are employees of the customer. In most cases, a working group is formed for these purposes. Provision for the services specified in the list. It can be carried out both in remote or distance and on-site format, depending on the customer's wishes. The period of service provision depends on the level of complexity and scope of work and is negotiated individually for each case. It's possible to provide a more time-consuming service for the formation of the cost engineering division in the organizational structure of the customer company, including such stages as recruitment, training, and development of business processes. A separate category of services included support for the formation of the technical requirements and technical assignment, which can be expressed both in filling out section economic indicators of the technical assignment according to GOST 15016 and in extended option for working with technical requirements and technical assignment, with additional visualization including tabular diagrammatic representation of technical assignment in the form of structural and functional models with an appendix in the form of set of analytical reports. The essence of filling the section of economic indicators of the technical assignment according to GOST 15016 is to introduce relative target limit indicators for the main units and systems into technical assignment. An example of filling in this section of the technical assignment was reviewed by us in issue number 10 of the training course. In the section List of available analytical reports, the reports that can be generated at the request of the customer and listed within the list of the available services. Let's describe this list. A report on the formation of structural and functional models, a report of determining the importance of function and function carriers, next, a report of the formation of diagram of relative values of RQS for function carriers, a report on formation of a diagram of absolute values in direct costs, or 6S for function carriers, a report on an assessment for the potential reduce in direct costs, or plan for activities for reduce the costs, and the last, a report on the assessment of the degree of satisfaction of customer and the end client. For the convenience of the customer, or more precisely for the customer to understand what exactly from the provided list we really needs and what he doesn't need, in the right part of the form, link to the videos describing the services and examples of their visualization and interpretation are posted. Let's look directly at the process of filling out the form. The general information block is located at the top of the form, which displays such parameters as case name, case description, deadline, top-level products, complexity level, and name of the object of analysis. Since in this example we are considering bicycle, the content, the fields, top-level product, and the name of the object analysis is the same. If we consider, for example, a front wheel bushing, then the content of these fields would be different. In the case description field, the most complete description of the tasks set by the analysis customer is entered, indicating the list of necessary initial data, i.e. a description of what we want to receive after the analysis in accordance with the sections list of available services and list of available analytical reports. Accordingly, the procedure for working with the general information blocks stages 1 and 2 will be as follows. At stage 1, the general information block is filled with the required output or output data. In the first approximation, the information about analysis and information about the project of analysis blocks are filled with impersonal data or plus signs, after which the form is transferred by the customer to the analyst. The analyst determines the list of available services and available analytical reports, taking into account the volume of initial data for analysis, fills in the blocks of list of available services and list of available analytical reports, and submits the form to the customer. At stage 2, the customer analyzes the list of available services and analytical reports specified by the analyst, taking into account the availability of initial data for analysis, then fills in the case description field in the general information block with the necessary output data, then fills the fields information about analysis and information about the object of analysis with numerical and textual data, and provides the analyst with access to process information required for the analysis. In the level of complexity of object of analysis field, we designate a conditional category of the level of complexity of the object of analysis in the design structure of upper level product. In our case, this is a product category, and the case of, for example, a front wheel bushing or bolt, a plus was put to the part category field. There is a place for the sketch in the right part of the upper block of the form. As a rule, at this level is enough to take either a screenshot of 3D model or bring an axonometric projection of the part from the usual 2D drawing, usual drawing. The purpose of filling in the place in the field place of a sketch is to form an honest general idea of the level of constructive complexity of the object of analysis and to create an opportunity to assess the complexity of analytical work. Next in the form are the blocks most identical in this content. The first one contains information about the analysis of the analyzed object. The second one contains information about the analyzed object or its variants. In this case, we analyze 3 analogs that are different stages of development and no one execution of the object of analysis that is a pre-production stage. In my opinion, it makes no sense to comment on the content of these blocks, since the names of the field or cells show that the purpose of filling them in is to establish a sufficient level description of such parameters of analysis and the object of analysis as availability of design engineering documentation, marketing information, technological information, basic life cycle parameters, and economic parameters for analytical work. Accordingly, depending on the level of complexity of analyzed objects, some fields may be left blank. For example, for the bicycle analysis object, fields such as structural material and assembly technology cannot be filled in. Since dozens of structural materials and assembly technologies are used in this analyzed object, so some fields will remain blank. For the object of analysis of front wheel bushing, on the contrary, filling in the fields structural material processes technology is not a problem. However, the field technical specifications will be blank, since no one will draw up technical specifications for a separate simple part. It should be noted that in some cases this list of required initial data can be expanded, in particular to conduct an analysis using the method of factory search, or MFR, which was discussed by us in issue number 9 of the training course. A significant amount of information related to design, strength, and technological data about the object of analysis will be required. In the context of considering the topic of practical application of value analysis or value design engineering techniques in design engineering, i.e. in the applied work of design engineer, the software of company A2Mac1 should be noted. If you go to the website of the developer of this software, it can be seen from the advertisement presentation that this software uses the concept of value as a tool for comparing the relative costs of various design options, which is completely identical to the concept of significance used to the evaluate functions for function carriers in the value analysis and value design engineering of domestic school. The A2Mac1 software is positioned by the developer as an application tool for benchmarking and reverse engineering. In turn, the value analysis and value design engineering is actively used in both of these areas, which will be demonstrated in the videos technical and economic benchmarking by value analysis and value design engineering tools, and reverse engineering with value analysis and value design engineering tools of block 1 of our training course. Without claiming absolute truth based on the above indirect signs, I would venture to assume that this software is an example of practical implementation of certain conceptual concepts of value analysis and value design engineering in application software designed for design engineers and specialists in other fields, for example, marketers, designers, cost engineers, and etc. That's all for today. All bye.